Hello. Okay. Hello, and welcome to the Studify Plus. In today's session, we will talk about the network analysis, and the topic we will learn today is two-port networks. Before going to that topic, before going to that topic, this is our batches. You can join these batches for structured learning. You can join Elite batch for 26-27, and we are having one more okay, these are the batches. Arjuna batches is also available, in which you are having live classes and recorded video, and everything is available to you, and you can contact on the numbers which is mentioned on the screen. Fine. So what is the agenda for the day? Agenda for the day is a very important topic known as two-port network. What we will study today, the topic is two-port network. What is two-port network? The idea of designing amplifiers, idea of designing transmission line, the idea of designing some filters. This idea of that design is known as two-port network. Two-port network means you have converted your big problem into one small problem, or you can say how your device will interact with other network. This can be identified with the help of two-port network. So what is meaning of two-port network? You can say two-port network is, what do we understand by port? This is one two-port network. In this two-port network, suppose we know the two-port parameters for some of the device. Let's say you know the two-port parameter for the BJT, or you know the two-port parameter for the MOSFET. Means which information is this two-port parameter is providing? The information provided by this two-port network is, let's say, in case of BJT, we are interested in the input impedance, input resistance. Let's say we are interested in this Ri. So who will provide you the information about Ri? Without knowing the internal circuit, of this box, we can identify the characteristics of this box, and this is known as two-port parameter. So this is also known as black box analysis. In this black box analysis, we are having four variable, two port. One port is this two terminal is known as one port, that is known as input port. Or port number 1, and these two terminals represent the second port or port number 2. Output port. That's why this is known as two-port network. So for any voltage current analysis, for designing any device, for BJT, MOSFET, for transmission line, for filters. All this requires certain parameters that how this devices will interact with the network, and for this that interaction some parameters, if we know some parameters, then it will be easier for us to show the to see the effect of this on network. And this parameters are given, this values are given by two port network. कि आपके पास अगर टू पोर्ट नेटवर्क में सपोज आई हैव वन बीजेटी, अगर इस बीजेटी के बारे में आपको ये पता है कि इसका इनपुट रेजिस्टेंस कितना है, तो आप ये पता लगा सकते हैं कि आपने सर्किट में जो लोडिंग लगाया, जो सिग्नल लगाया है, वो कितना लोड होगा अक्रॉस द बीजेटी। या फिर हम ये पता लगा सकते हैं कि मैक्सिमम पावर ट्रांसफर की कंडीशन क्या बनेगी किसी भी लोड के अक्रॉस। तो ये सारी बात पता करने के लिए हम जो एनालिसिस करते हैं दैट इज टू पोर्ट नेटवर्क। ऑलवेज रिमेंबर, in two port network no independent sources are allowed. These are having only dependent sources or resistive, capacitive, inductive network in case of AC and resistive network in case of DC. So to analyze BJT, MOSFET, transmission line, filter, to analyze and to design this, we need two port networks. So two port network is very important for designing this MOSFET, BJT filters. And how you can characterize the two port network? So you can say we are having four variables. एक वेरिएबल है मेरे पास वोल्टेज V1, एक वेरिएबल है मेरे पास करंट I1, एक मेरे पास है V2 और एक है मेरे पास I2। करेक्ट। तो चार वेरिएबल हैं और दो पोर्ट हैं। चार वेरिएबल और दो पोर्ट से जो कॉम्बिनेशन बन सकते हैं वो कितने बन सकते हैं? 4C2। टोटल नंबर ऑफ कॉम्बिनेशन from four variable at two port from four variable at two port will be what? This value will be 4C2, which is 4 factorial divided by 2 factorial, which is 24 divided by 4, the value is 6. So 6 parameters are possible for this. How many parameters are possible? 6 parameters are possible for this. So suppose you want to analyze BJT. Which parameters are important for BJT? Suppose we are drawing the two-port network for BJT. The voltage gain is one of a very important parameter. Input resistance is one of very important parameter. Output impedance is one of very important parameter. So to define means how your transistor will interact with the network. To understand this, we need this two-port parameters. So there are 6 parameters are possible. And what those 6 parameters? So first parameter is known as Z parameter. Or also known as open circuited parameter. Or also known as impedance parameter. Then we know the second parameter is Y parameter. Then next parameter we will learn after Y parameter we are having H parameter. Fourth parameter is G parameter. Fifth parameter is T parameter. And sixth parameter is inverse T parameter. Which parameter is important for us and which is mentioned in our syllabus? We will talk about Z parameter, we will talk about H parameter, we will talk about T parameter, and G and I we can design any kind of parameter, so we will analyze this point also. What is next? The next point is very important. What is important for the exam? So sometimes they ask question directly, sometimes you will get question like this. These are two important category of questions. Important for two parameters. Important. What is important for this? Sometimes they ask question on Thevenin's equivalent, plus two port. So you will get question on Thevenin's equivalent plus two port. This is a very important category. What is next? Maximum power transfer plus two port. So this type of question you will get in your exam. This is very two important categories. So we will solve the two port network. We will solve the two port network for resistive network, for network having some dependent sources, but they ask question from these two categories also. Maximum power transfer for plus Thevenin's and maximum power transfer Thevenin's plus two port and maximum power transfer plus two port. ये दो important category है. So ये दो important categories. शुरू करते हैं आगे. हम फर्स्ट पैरामीटर के बारे में बात करते हैं और जानने की कोशिश करते हैं कि वो पैरामीटर क्या बताएगा. The first parameter is what? The first parameter is known as Z parameter. And what do we understand by Z parameter? Z parameter is also known as impedance parameter. Impedance parameter means वो पूरे नेटवर्क की impedance characteristics बताएगा कि input impedance कितना है, so that you can have idea about loading. Output impedance कितना है, so that you can have idea for the maximum power transfer. So you can talk about you can analyze your device. What device? BJT, MOSFET, transmission line and filters. So let's talk about first parameter, and the first parameter is known as Z parameter. First parameter is known as Z parameter. So in Z parameter, how you define the parameter? The parameter is defined by this. This parameter is known as Z parameter. Here we are having this is P2, this is I2, output voltage, output current, and two variables we are having at input, P1 and this is I1. V1 and I1, always focus that direction of current is inside the network. Direction of current is inside the network. And this network is known, this is our two-port network. What I want to do with this two-port network, I want to write V1 as a function of I1, I2 and V2 as function of I1, I2. If I write this, then I can say my network is what? This parameters will be what? Z parameter. So in this case, which one is independent variable? If I am writing V1 as a function of I1 and I2, so V1 is what? V1 is dependent variable while I1 and I2 are independent variable. What is the meaning of independent and dependent variable? The meaning of independent and dependent variable is very simple. A user can select the value of I1 and I2. So these are independent variable because user can control it, and V1 and V2 is the result because of this is applied to the two port, maybe BJT, MOSFET or transmission line. So can I say I1 and I2 here independent variable while V1 and V2 are known as dependent variable. So two types of variable available here. One is independent variable and another variable we are having is dependent variable. Independent variable and dependent variable. How we can write it? The two-port parameter we can write it V equal to matrix of Z into matrix of I. This is which parameter? This is known as Z parameter. So we are having what is the first we are having the two ports, so we will write the voltage V1 and V2. So and Z, and we will write I1 and I2. So can I say if I expand this, if I expand this, I can write V1 V2 a 2 cross 1 matrix is equivalent to Z11, Z12, Z21, Z22 into I1 and I2. Always remember V1 and V2 represents the voltmeter. Always remember here what is V1 and V2? V1 and V2 are the reading of the voltmeter. Because what is independent variable? So independent variable is I1 and I2. Means you are supplying I1 and I2 to the network, and what you will measure? You will measure V1 and V2 for the network. So always remember, whenever I say in two-port network we are learning the Z parameters. So learning the Z parameters or analyzing a device with the help of Z parameter means you are supplying I1, I2 and you are measuring what? V1 and V2. So this is the idea. So you can say V1 and V2 are the reading of the voltmeters, while I1, I2 you are supplying to the network. Always remember direction of I1 and I2 is inside the network. So I can say the equation we can write here is what? Equation we can write here, what is V1 V1 is Z11 I1 plus Z12 I2. And what is V2? V2 is represented by Z21 I1 plus Z22 I2. These are two equations which we have obtained from here. Which is obtained from here. V1 equal to Z11 I1 plus Z12 I2 and Z21 I1 plus Z22 I2. What this equation represents? Let's talk about this equation. So you know that the V1 and V2 are what? The reading of the voltmeters are dependent variable. Dependent variable means what we are measuring for the circuit. And independent variable means what? What user is supplying to the network is known as independent variable. Correct. So let's make this analysis. What we are saying, this is our two-port network. And in this two-port network, we are calculating the parameters. So how to calculate the parameter? The same thing we will do with the circuit also. Here we are having this is one two-port network, and what we are trying to figure out for this, we are trying to figure out that we will try to figure out that suppose this is your V2 and this is your V1. This current is I1. This current is I2. Both are going inside the network, I1, I2, and we are having here a Z parameter. So this is our Z parameter. What is the first analysis? First analysis is we are having independent variable I1 and I2. So let's make step number 1 to approach the network. What is step number 1? Step number 1 is make I2 equal to 0. Make I2 equal to 0. Make I2 equal to 0 means output port is open circuited. Output port we are replacing our output port by what? We are replacing our output port by open circuited. Output port is replaced by open circuited. If I make I2 equal to 0, can I say what are the variables available now? If I2 equal to 0, you are connecting one voltmeter here. You are calling this voltmeter reading as V1, and you are connecting another voltmeter here, and you are calling this reading as V2. So you are having I2 equal to 0 and calculating the reading at port 1 and port 2. So can I say if I make I2 equal to 0 in our equation, V11 will be what? Z11 into I1 plus Z12 into I2. If I make I2 equal to 0, this term will be 0. And if this term will be 0, we are having the first parameter, and that first parameter is what? V1 divided by I1. By making I2 equal to 0, And this parameter is what? This parameter is known as Z11 parameter. Also known as open circuited input impedance. Which port is open circuited? The ratio of input voltage to input current is known as Z11, and which port is output open circuited? Output port is open circuited. So you can call it driving point impedance or open circuited input resistance, and that parameter is known as which parameter? Z11. Always remember, Z11 is the ratio of V1 and I1. V1 divided by I1 by making I2 equal to 0, and that parameter is known as Z11. Always remember, the first one comes from the numerator and the second one comes from the denominator. Input impedance or driving point input impedance of this two-port network. Just wait for a minute. So first one comes from numerator 1 and second one comes from denominator. What is next? The next parameter comes from the second equation, and what second equation says? Second equation says that V2 is equivalent to Z21 I1 plus Z22 I2. If I am making I2 equal to 0, I will get I2 equal to 0 because output port is open circuited and you are taking reading from V1 and V2. So can I say, and you can select any value of I1. These are not variables. When you supply, means you are doing this using some source generator and V1 and V2. So voltmeter and source generator. So you can select any value of V1 and any value of I1. 1 ampere, 2 ampere, 3 ampere, any ampere is fine. And what we can say, the V2 divided by I2, V2 divided by I1, that parameter is known as Z21. And this is known as what? By making I2 equal to 0. So you are measuring the voltage at which terminal? Output terminal. You are measuring the voltage at which terminal? Output terminal. So we can call this resistance as, because V by I ratio always represent resistance, and whenever you connect one variable, you take one variable from input, another variable from output, that term is known as trans. So this is transfer or you can say this is trans output resistance. Because your voltmeter is connected at output and you are supplying current at input. So this is known as trans output resistance of the two-port network. And this is the analysis with respect to port 1, because port 1 is there, the port 2 is open circuited. Means in the first case we are taking I2 equal to 0. This is independent variable, so you can make it 0 or 1 or 5 or 10, you can take anything. Now the same analysis I can have for port number 1. So I can make, we are having two equations, V1 equal to Z11 I1 plus Z12 I2, Z11 I1 plus Z12 I2 and V2 is equivalent to Z21 I1 plus Z22 I2. Now what we are doing in the same, we are applying the same rule again. What I am doing, I am replacing input port by open circuit, means I am making I1 equal to 0. So what is in your hand? Dependent variable is in your hand. So what we are doing, we are making I2 equal to 0. We are taking the reading of 2 voltmeter which is connected in input port and output port. Again we are making I1 equal to 0 and we are taking reading at input port and output port. So you can say let I1 equal to 0, or you can say input port open circuited. Input port we are making input port open circuited. If I am making input port open circuited, can I say if I am making I1 equal to 0, what is the first observation we are having? The ratio of V1 divided by I2 by making I1 equal to 0. So you are having your voltmeter at input port. So this is known as trans input impedance. Transfer or trans input resistance. What else we are having? And this parameter is what? This parameter is known as Z. This first variable come here and second variable go. So this is Z12. So if you write I1 equal to 0, what this variable is? Z12. What next? The next is by making I1 equal to 0, we can analyze the port 2. And what is port 2? Port 2 V2 is equivalent to I1 equal to 0. So you can say this is Z22 into I2. Z22 into I2 and V2 divided by I2 by making I1 equal to 0. That parameter is known as Z22. And what is meaning of this? The meaning of this is output resistance. This is what? Output resistance. And this is a standard method of calculating the output resistance. How you calculate the output resistance? The idea is very simple. What we did in this parameter is telling you about what? This parameter is telling you about calculating the equivalent resistance. How you calculate the Thevenin's resistance? So make every independent source equal to 0 and calculate the voltage, test voltage divided by test current ratio. And test voltage divided by test current ratio, this is also known as impedance or resistance, Thevenin's impedance or Thevenin's resistance. So to calculate this parameter, to know these characteristics, we are interested in all these parameters, Z parameter. So you can say, whenever I am saying that something is a Z parameter for a two-port network, Z11, Z12, Z21 and Z22, what I can say? I can say that there is a meaning of Z11. What is meaning of Z11? Z11 is ratio of V1 divided by I1 by making I2 equal to 0. This is ratio of V2 divided by I1 by making I2 equal to 0. And what is Z12? V1 divided by I2 by making I1 equal to 0. And what is one parameter? One more parameter is Z22, that is ratio of V2 divided by I2 by making I2 equal to 0. This four Z port two-port network is available. 4 Z parameters are available, which is known as Z11, which is known as Z11, Z12, Z21 and Z22. Okay. There are two conditions also here. The one condition is known as symmetrical network and reciprocal network. So symmetrical network and reciprocal network is very same. If input impedance is equivalent to output impedance, that network is known as symmetrical network. Or we will discuss the symmetricity and reciprocity of this network very clearly. Now just focus on this. Everything is clear from the Z parameters point of view. Now how many types of question they can ask? First try to develop this question solving skill, then we will try to analyze that what information we can have. By looking at the Z parameter, can we identify whether our network is reciprocal or not, whether our network is symmetrical or not? We can answer about everything. So you can divide this question in the how many categories? 4 or 5 categories we can divide the question. But if I want to draw the equivalent of this, electrical equivalent of Z parameter, I can draw it. Let's say I am interested in the electrical equivalent of Z parameter. Electrical equivalent of the Z parameter. So what equation we are having? The equation we are having is Z11 I1 plus Z12 I2, and second equation we are having is Z21 I1 plus Z22 I2. These are the equations we are having. If these are the equations we are having, can I say we are having two ports. So let's say I am making one port common to input and output. What is first thing? First thing, you are having Z11. So this is your input port. I am writing it Z11. This is the electrical equivalent of Z parameter network. So this is, let's say, Z11. And let's say this current is what? I1. I am calling this voltage as V1. So you can say, what is V1? V1 is equivalent to Z11 into I1. What we want? Z12 into I2. So let's say, but I2 current is not available here. I2 current is the current of the second port, output port. So you can say we have to use one dependent source here. And what this value will be? This value will be plus minus of Z12 into I2. So this is implementation. Port 1 is implementation of our first equation. Port 1 is what? Implementation of our first equation. What is port 2? At port 2 we are having output impedance. Let's say I am calling it Z22. I am calling this as Z22. I am calling this as a Z22. Then we are having what? This is V2. And this current is what? This current is I2. So what we are having? Z22 into I2. And what is one more parameter? Z22 into I2 plus Z21 into I1, but I1 current is available at port number 1. So you can say, I can write this plus minus of Z21 into I1. This is the electrical equivalent of what? This is the electrical equivalent of two-port parameter network. Now, what we are saying that we have to find the condition for reciprocal and symmetrical network that we will calculate. But first, this is the electrical equivalent of two-port network. Let's calculate the two-port parameters for some of the networks. So let's take the first example. What is the first example? The first example is this. Example number 1. Let's say you are having this network. A T network. This is 1 kilo, 2 kilo, and 3 kilo. And this value is what? This value is, I am calling this as a V1, I am calling this as a I1, I am calling this as a V2, and I am calling this as a I2. This is our network, and I am interested in the Z parameter. We are interested in Z parameter. So you can say we are interested in V1 divided by I1 ratio by making I2 equal to 0. And we will call this parameter is equivalent to Z11. So if I make I2 equal to 0 for this network, if I take I2 equal to 0, this current is 0, so this potential drop is also 0. So how much current will flow through this network? Here I1 into 1K and I1 into 2K. Because this current is 0, if I take this current I2 equal to 0, what kind of current we can expect in loop number 1? So current we can expect V1 equal to how much? Only one current. Initially this 2 kilo ohm resistance is shared by two current I1 and I2, but here means I1 current is coming from here, I2 is coming from here. So can I say the net current going inside the network is I1 plus I2, but I am making I2 equal to 0. So what is current here? I1. So you can say V1 is equivalent to what? V1 is equivalent to what? V1 is equivalent to, इसका वैल्यू हो जाएगा I1 plus 2 times of I1. So I1 plus V1 divided by I1 by making I2 equal to 0. This value is 3K. So what is Z11 parameter? Z11 parameter for this network is 3K. 3 kilo ohm resistance. This is it, input impedance, or you can call this parameter as Z11. Now which parameter we want to calculate? We want to calculate the parameter which is V2 divided by I1 by making what equal to 0? By making I2 equal to 0. If you go for this, what I can say, if you make I2 equal to 0, the potential drop across this component is 0. So only you are having potential drop across 2 kilo ohms. So you can say this is nothing but 2K, and this parameter is known as Z21. Why I am writing this? Because when you apply the KVL, here, you can say V2 is equivalent to 2K times of I1. And I am interested in this ratio. So V2 divided by I1 ratio is what? V2 divided by I1 ratio is 2K. V2 divided by I1 ratio is what? 2K, which is mentioned here. Now, this is the port 2 parameters when you are making I2 equal to 0. What is next thing? Next thing we will make I1 equal to 0. So in the same circuit, let's make I1 equal to 0. You are having 1, 2 and 3. Okay. 1, you are having this as 1, 2, this is 1, this is 2, and this is 3. Correct? What else we need? Let's make I1 equal to 0 now. Input port open circuited. If I make input port open circuited, can I say this is our V1, this is our V2, और यहां जिसकी हम वैल्यू मेंशन कर रहे हैं वो है I2. तो बहुत आसान तरीके से हम ये बता सकते हैं यहां कि तो 1 किलो ओम के अक्रॉस जो पोटेंशियल ड्रॉप है वो उसका वैल्यू होगा 0, बिकॉज I1 करंट 0 है. एंड व्हाट इज पोटेंशियल ड्रॉप अक्रॉस दिस? सो KVL अगर लूप नंबर 2 में लगाया जाए तो कितना होगा? The source voltage is equivalent to sink voltage, so you can say V2 is equivalent to how much? 3K plus 2K into I2. ये दोनों आ जाएंगे सीरीज में क्योंकि करंट सेम है, यहां से 0 करंट आ रहा है और 2 किलो ओम रेजिस्टेंस में जो जाने वाला करंट है दैट करंट इज I1 प्लस I2. अगर ये करंट I1 प्लस I2 है एंड इफ आई एम मेकिंग I1 इक्वल टू 0, व्हाट यू आर हैविंग 3K प्लस 2K, so you can say that the ratio of V2 divided by I2, that is known as I1 equal to 0, and that ratio is what? Z22, और Z22 का वैल्यू जो आया है वो आया है 5 किलो. करेक्ट? What else we need for this? एक और पैरामीटर जिसकी हमें रिक्वायरमेंट है वो पैरामीटर है कि जब I1 आपने 0 कर लिया तो आपने V2 का वैल्यू मेजर कर लिया. नाउ वी आर इंटरेस्टेड इन द कैलकुलेटिंग द वैल्यू ऑफ V1. तो वैल्यू V1 का वैल्यू पता करने के लिए इनपुट लूप में KVL लगा दिया जाए तो कितना हो जाएगा? V1 इक्वल टू पोटेंशियल ड्रॉप अक्रॉस 1 किलो ओम इज 0 बिकॉज करंट इज 0, एंड दिस वैल्यू इज व्हाट? दिस वैल्यू इज 2 टाइम्स ऑफ I2. So this parameter is V1 divided by I2 by making I1 equal to 0, and that parameter is known as Z12. तो हमारे पास 2 पोर्ट नेटवर्क के सारे पैरामीटर हैं, लेकिन अगर आप ध्यान से देखें तो what is Z1 we are having? आप देखें कि अगर मेरे पास एक T सेक्शन अवेलेबल है तो I don't need to analyze this network, I can write answer directly. कि अगर मैं I2 को 0 करता हूं तो ये दोनों सीरीज में आ जाएंगे, तो इनपुट वोल्टेज डिवाइडेड बाय इनपुट रेजिस्टेंस, तो इसका Z11 पैरामीटर कितना हो जाएगा? 1 और 2, 1 और 2 कितना? 3. तो यू कैन डायरेक्टली राइट इट कि Z11 जो पैरामीटर होगा एक T सेक्शन का, इफ आई से let's say for a T section you are having, let's say this is your T section. T सेक्शन से आप पैरामीटर्स को डायरेक्टली स्टडी कर सकते हैं. This is R1, this is R2, this is R3. करेक्ट? इस स्टार नेटवर्क के लिए सपोज आई एम इंटरेस्टेड इन द T पैरामीटर्स, सो T पैरामीटर यू कैन डायरेक्टली राइट. This is V1 and you don't have to remember it, you can write it by logic. V1, this is I1, this value is V2, this value is I2. I am saying that I am interested in writing the 2-port network for this, 2-port parameter for this. तो पैरामीटर लिखने के लिए देखें जरा, जब आपने I2 को 0 बनाया, when you are taking I2 equal to 0, these 2 resistances will appear in the series. So this is what? V1 is equivalent to R1 plus R2 times of I1. So what is your input parameter? Z11 R1 plus R2. करेक्ट? तो आपने क्या किया? मेजर कर लिया किसको? I2 को 0 करके. तो I2 को 0 करके आपने V1 मेजर किया, एक बार I2 को 0 करके आप किसको मेजर करेंगे? V2 को मेजर करेंगे. तो जब आप V2 को मेजर करने जाएंगे तो R3 के अक्रॉस तो पोटेंशियल ड्रॉप 0 हो गया बिकॉज I2 इज 0. तो व्हाट यू विल गेट, V2 इक्वल टू R2 I1 multiplied by R2. So you can say the parameter V2 divided by I1, Z21. And what is Z21? That parameter is equivalent to R2. Likewise, इसी नेटवर्क में अगर आप R1 को 0 करेंगे, if you make I1 equal to 0, if you make I1 equal to 0, the I2 same current will flow in this two resistances. The same current will flow in these two resistances. Then what is the value of V2? The V2 is R2 plus R3 multiplied by I2. So you can say this value is what? R2 plus, or let me write it here. This is Z22. So Z22 is R2 plus R3. और अगर आपने I1 को 0 करके अगर आपने बोला है कि मुझे V1 में इंटरेस्ट है, तो V1 का वैल्यू कितना हो जाएगा? इफ यू आर मेकिंग I1 इक्वल टू 0, तो पोटेंशियल ड्रॉप अक्रॉस R1 इज इक्वल टू 0. सो व्हाट यू विल गेट? R2. तो आप ऑब्जर्व करेंगे जैसे हम आगे बढ़ेंगे कि जब भी केवल एक रजिस्टिव नेटवर्क आता है तो वी वांट टू कन्वर्ट दैट रजिस्टिव नेटवर्क इनटू स्टार नेटवर्क, है ना. दिस इज नोन एज स्टार नेटवर्क. व्हाई वी वांट टू कन्वर्ट? Suppose even if a delta is given, we want to convert it into the star network. Why we want to convert it into the star network? Because it is easy to write the Z parameter for a star network. This which type of parameter it is? Z parameter. जैसे इस कॉन्सेप्ट पे एक क्वेश्चन गेट 2025 में भी आया है कि आपको एक डेल्टा नेटवर्क दिया है और उसके लिए पूछा है कि Z पैरामीटर कैलकुलेट करो. तो आंसर ये है उसका कि उस डेल्टा को आप स्टार में कन्वर्ट कर लो, सो दैट यू कैन answer it directly. By looking at the network you can answer it. What is Z11? Sum of this two. What is Z22? Sum of this two. And what is Z12 and Z21? This is R2. I hope this is clear. Now let's calculate few more two-port parameters. What is next? Next we are having the two-port example number 2. Example number 2. Let's calculate the two-port parameter for this network. This value is R. And we are interested in calculating the two-port network for two-port Z parameter for this network. I am interested in calculating I am calling this value as 1. This value is I1. This value is V2. This value is I2. Correct? Now again you can write the Z parameter very easily. Not by remembering the formula, you can write it directly. What is Z11? So you are making I2 equal to 0. If you are making I2 equal to 0, what is we are having here? You are having the resistance R here. Because V1 equal to what? I1 into R. So this is R. If you are making I2 equal to 0, what is V2? V2 is also I into R. So this value is also R. If you are making I1 equal to 0, so if you make I1 equal to 0, so only current which is going inside the resistor is what? R. So what is V2 equal to? V2 equal to I2 into R. So you can write this parameter as R. And V1 equal to what? V1 is what is value of V1? V1 is equivalent to I2 into R. So this parameter is also R. This is Z parameter for the resistance available here. But Z parameter is not defined when current I2 and I1 are dependent on each other. Z parameters is not defined, very important point, point for Z parameter. Point for Z parameter. And what I can say the point for Z parameter is, the point for Z parameter is what? That when I1 and I2 are dependent, I1 is dependent on I2, or I2 is dependent on I1. In these two situations, the Z parameter is not defined. That's why a very popular saying that Z parameter is not defined for the transistor. Why it is not defined for transistor or any network which is having this property? So let's take first example where Z parameter is not defined. Can I say I have one simple resistance and this resistance is having value R. I am interested in Z parameter of this network. So whenever we are interested in calculating the Z parameter of this network, this value is V1, this value is V2, we are calling this as I1, we are calling this value as I2. Now what we are saying that I1 and I2 are dependent on each other. If I make I1 equal I1 and I2, so here you can observe that I1 and I2 are the current in the same branch. I1 and I2 current in same branch. I1 and I2 are current in the same branch. So the moment I make I2 equal to 0, the moment I make I2 equal to 0, I2 equal to 0, this will force to make I1 equal to 0. Because if you apply the KCL here, I1 plus I2 equal to 0. If I apply KCL at this point, what I can say? Both are incoming current. So both are incoming and nothing is outgoing. So I1 plus I2 equal to 0. Or you can say I1 is equivalent to minus of I2. But if I am making my independent variable 0, if I am making I2 equal to 0, if you make I2 equal to 0, I1 will be automatically 0 because I2 is totally dependent on what? I1. Or I1 is totally dependent on what? I2. So in this case, you are making I2 equal to 0. So parameter you calculate is what? V1 divided by I1 by making I2 equal to 0. If you say I am making I2 equal to 0, this I2 equal to 0 will make this I1 equal to 0. So you can say this Z1 parameter is what? Infinite. If you are interested in another parameter, what is another parameter? You can calculate the V2 divided by I1. And you are making I2 equal to 0. If you are making I2 equal to 0, I2 equal to 0 will make I1 equal to 0. And that parameter is Z21. So some V2 divided by 0 value is what? Again infinite. So, and this is true for the another network also. This is true for another network also. What is another? If you make I1 equal to 0, you can say I1 equal to 0 will force this I2 equal to 0. So, which parameter you are interested in? V2 divided by I2 by making I1 equal to 0. But I1 equal to 0 will make I2 equal to 0. So this parameter is again V2 divided by 0 and that is Z22 which is infinite. And V2 divided by V1 divided by I2 by making input port open circuited, that is V1 divided by 0, because V1 equal to 0 will force that I2 equal to 0, and that parameter is Z1, 2, that is also infinite. So can I say when current are dependent on each other, means then in that condition all parameters are what? Infinite, not defined. So Z parameter is not defined for this network when I1 and I2 are directly dependent on each other. I hope this is clear. Correct? Let's take one more example. So if we are, what is the condition for existence of Z parameter? So you can say Z parameter is valid only if I1 and I2 are independent to each other. We don't want dependency in I1 and I2. So let's take one more example of this, and that is, let's say you are having one transformer. Example number 2, where Z parameters are not valid. So let's take this. This is one transformer. This value is V2. This value is N/1 turns ratio. And we are calling this as V1. I am calling this value as I1. I am calling this value as I2. What we can write? From this theory we can write V1 divided by V2 is equivalent to what? V1 divided by V2 is equivalent to N by 1. And this ratio is equivalent to I2 divided by I1. Transformers equation. So you can say